All right, welcome. Today we're going to kind of talk about this lab that we kind of did and the properties of ionic and covalent and metallic bonds. So a couple things to note right off the bat is that in our introduction, we saw that salt was the ionic, cornstarch was the covalent, and aluminum was the metallic. So with that, we can kind of make some ideas about it. So first thing right off the bat is that if we're basing all our ionic properties on salt, we expect it to dissolve. We expect ionics to conduct in water, but not outside of water. Furthermore, we expect nothing to happen when it burns. If we take covalent molecules to be the same way as cornstarch, then we expect them not to dissolve, not to conduct outside of water, but when you apply heat, it'll burn. If we take metallic bonds based off aluminum, we expect it not to dissolve, not to conduct in the water. And by that, I mean the water solution with aluminum does not conduct. Of course, if you touch the piece of aluminum inside the water, that will conduct because that's the same as conducting outside of water. As for melting and burning, we expect nothing to really happen. So now I've made up some random unknown C, which does dissolve, does conduct in water, does not conduct out of water, and maybe it has a slight reaction to heat. You'll notice that all of your unknowns have a little bit of both sides. They're not straightforward like salt, cornstarch, or aluminum, and that's on purpose. So when we write a CER or a claim evidence reasoning, first thing we want to start out is the claim is going to answer the question. And already I saw a lot of papers that didn't do this, but I will say based on these properties where unknown C behaves like an ionic for two of them, behaves like a covalent kind of for one of them, and then kind of behaves like both. So conducting without water, we can't really gain any information from. And that's important to see. If there is a property that both ionic and covalent have, and your unknown also has, that doesn't tell you anything. Because just looking at this column alone, if I solely look at this column, I can see that the only thing unknown C not conducting outside of water tells me is it's not aluminum, therefore it's not metallic. That's the only thing we can tell, that it's not metallic. So with that said, I have two things that tell me it's ionic, one thing that tells me it's possibly covalent, possibly ionic. So I'm going to lean towards the side of ionic. So I'll write in my claim, I believe unknown C is ionic. Now, the first problem I had is a lot of people didn't tell me what unknown they had because this on your chart said A/B because you could have chosen either. But then when you wrote your CER, you didn't tell me what it was. You didn't tell me which one you chose. So you got to tell me, are you choosing A or B? All right. As for the evidence and reasoning, this is where you take each piece of evidence and then relate it back to the claim. So I can just separate this out pretty easily. So if I want, you can write it as a paragraph, and that's great. And if it's hard for you to do that, then I'm going to just write it as evidence one. And let's say that my first piece of evidence is that the unknown dissolved in water. That is evidence. Evidence is just a statement of fact based on data. Now we have data right here that says unknown C dissolved in water, and that's my evidence. My reasoning to go with that is because salt dissolved in water and is ionic, I can conclude that when unknown C dissolves in water, it is exhibiting an ionic property. Bam, that's an evidence and a reasoning. that very concisely says, this is what happens, and that's why I believe it is this. If you'll notice, evidence 1 doesn't actually claim whether or not it's ionic or covalent or metallic. It simply states a fact. The reasoning is where you take what is stated and connect it back to the claim. This is where you take it and bring it all the way back to the claim. So you take this and bring it right back around, and that is how you go about that. So with evidence 2, I'll kind of write it more paragraph-wise. The second piece of evidence I have is that our unknown conducted electricity when dissolved in water. As our ionic compound also conducted electricity, this leads me to believe that unknown C has ionic bonds. Now, the other part of reasoning is being able to use scientific principles. We haven't really gotten that far for the scientific principles about why this works unless you read ahead, or actually it was in the book. So we can say as ionic compounds dissolve, they break into their individual ions, which carry charges and can transport electrons through the water, therefore conducting electricity. So what I'm going to do really quick is I'm going to just color code these a little bit to break it down. Oh, oops, my bad. I'm going to go ahead and color code evidence green. And I'll color code my reasoning. I don't know, I'm feeling blue. You'll notice reasoning 2 has a lot more to it because when you have scientific principles that can back up your evidence, you want to input those in your argument. It shows that you understand what's actually going on, and you can relate it back to a scientific principle that also backs up your argument. So something to finally add is you might want to add some sources of error or some points of contention or confusion. One piece of evidence that is contrary to my claim is the fact that there was some reaction to heat where the substance, what did I say? Substance got a little darker. This would imply a covalent bond is present. However, I do not believe this is enough evidence to imply a covalent bond, as it did not burn like cornstarch. And so now I'm just including a little bit of opposition, mostly to show that I'm not just ignoring facts. It shows that I'm considering all angles. So when you finish this, you can leave it like this. You can always write a little conclusion statement. In conclusion, due to the first 2 properties listed above, unknown C is likely ionically bonded. And we're done. It's like 6 sentences, 7 sentences, so it doesn't take that long. You just saw me do it in about 5-6 minutes. but it's concise. It really states every single piece of evidence that I took into consideration. You may want to include instead this, conduct without water. You can say, while it did not conduct without water, which is similar to both ionic and covalent, it is unlike a metallic bond, which would have conducted electricity. So you can say, you can knock that out of the running, but I don't feel that is as important as specifically the pieces of evidence that point to your argument. So I hope this helped, and yeah, have a great day.